quadrilaterals. So first, what you can do is look at them and see what kind of quadrilateral do you think it is. What kind of quadrilateral does it look like? Huh? It looks like kite, but that doesn't mean you can just write kite. You have to prove it. So what was the characteristics of kite? Two adjacent sides are equal. We can show the length of these two are equal. Length of these two are equal. What else for the kite? They are yes. Diagonals are perpendicular. Can we find the slope of these two diagonals? Yes. But let's go ahead and find the length of each side. So measure of length xy, measure of length yz, and we are assuming those two, predicting those two are equal, but you have to show it. So square root of, if you use a Pythagorean theorem, it's 1 up, 4 to the right. So it is a squared plus b equals to c squared. So it is 1 squared plus 4 squared. And you square root it, so you get square root of 17. Can I actually just leave it as square root of 17? Yes. Why? Because we are just comparing if they're equal or not. What about yz? Oh, it's 4 and 1, so we already know 1 and 4, they're equal, but still show the work. 1 squared plus 4 squared equals to square root of 17. So these two are what? Same. What about measure of xw and measure of wz segment? Square root of zw. Let's do xw first here. So it is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. So it is 7 squared plus 4 squared equals to square root of 49 plus 16, which is square root of 65. Let's just leave it like that. What about here? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. So it has the same dimension, 7 by 4. 7 by 4 diagonal, so we already know they are same, but you have to still finish your work. 7 squared plus 4 squared must be square root of 65. So these two are congruent. So for kite, is that enough work to show they are kite? I think so. But on the question, they might say, use their diagonals. Then what are they asking? They want to know their length are different, and it's 90, right? You cannot just say they're perpendicular because square had a perpendicular diagonals. Rhombus had a perpendicular diagonals, but this will have a different length. So even though this is enough work, let's go ahead and still check if the diagonals are perpendicular. So we can say the slope of the diagonal, which is WY, segment WY equals to, slopes are not too hard, right? You just got to count it. It is this whole thing. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Oh. Because it's, yeah, I didn't draw it accurately, but I guess it's 1 by 1. So what's the slope? 8 over 8, rise over 1, which is 1. Then this slope must be what? -1 if it's perpendicular. Is it? Down 3, run 3. So slope of xz is -3 over 3, which is -1. Are they reciprocal? So 1 over 1, 1 over 1. And opposite, so yes, they are perpendicular. So it is, you have to explain it. So 2 pairs of what? Adjacent sides are what? Congruent, and diagonals or what? Perpendicular. Therefore, it is a kite. Yes? Yeah. Yeah, because, I mean, I will understand why you did this, but what does it say, really? Two pairs of sides are congruent. Diagonals are perpendicular. Therefore, you have to write the conclusion statement. Therefore, it is kite. So let's do one more together. So what about this one? What does it look like? Parallelogram. So for parallelogram, what do you have to say? What do you have to prove? Opposite sides are parallel. Is that all? I think so, right? Parallelogram, that's all you have to prove. Would this be rhombus? Let's go ahead and look at the sides, and if it has all equal sides, it's rhombus, not parallelogram. Because you have to give me the most accurate name. And if it's only opposite sides are congruent, then you can say it's parallelogram. So most of the cases, you're going to find all the slope and all the length. Okay? So let's start from slope, because slopes are easier, right? So let's just write slopes here. So segment AB, segment DC, segment AD, segment BC. So AB, 2, 3 up, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you could have done 1 over 3, 1 over 3, but just to make sure, it's better to use the whole thing and simplify. But if it's obvious that it goes through the right in the corner of grid, you can use 1 over 3. So 3 over 9 is 1/3. What about DC? Is it 1 over 3? 1 over 3? 1 over 3? Yes. So it is 1/3, meaning these two are parallel. What about DA? Always go from left to right, okay? So it's going up. 1, 2, 3, 4, 5, 6, 7, 8 over 1. So it is 8 over 1, which is 8. Here, 1, 2, 3, 4, 5, 6, 7, 8 over 1. So it is same slope. So these two are parallel. So now, what type of parallelogram is it? It could be just parallelogram or rhombus, right? So now let's find the length of each side. So length of AB and BC, DC, and AD. So AB, so it is 3 by 9, so just use the Pythagorean theorem. It's 3 squared plus 9 squared, which is square root of 9 plus 81, 90. Let's just leave it as it is. Okay? BC, the next one is 8 by 1. So it is 8 squared plus 1 squared, which is 64 plus 1, 65. DC, 1, 2, 3. Didn't we find the, oh yeah, we just did this rather than counting it all. So it is 9 and 3. So it must be same as AB. 3 squared plus 9 squared is square root of 90, just like segment AB. So we already know it's parallelogram, right? Only opposite sides are congruent. But still, you have to finish your work. So AD is square root of 8 by 1. So 8 squared plus 1 squared, which is square root of 65. So these two are congruent. These two are congruent. So this is equal to that side. This is equal to that side. So what is your final conclusion? You're going to say 2 pairs of what? Opposite sides are parallel. And 2 pairs of opposite sides are what? Congruent. Therefore, it is just parallel. What does it look like? Rectangle. So let's see if it has all 90 degrees and opposite sides are equal. Classify the quadrilateral below. Be as specific as possible, so you have to show all the work. So let's start from the length of each side. When you look at this, it looks like a rectangle. So we have to prove it has all 90 angles, perpendicular angles, and opposite sides are congruent. Let's start from the size. So measure of length AD, measure of length BC. Can we just show they're all 90? Square can have all 90, so still show the length. So only 2 pairs of the opposite sides are congruent, not all 4. So let's find the length first, measure of DC and AB. So here, what is it increasing by? Is it increasing by 2? Can't really read it. Can you guys read it? 2? Yeah, look at the other ones. It's by 2s. So this is 0, 2, 4, 6. So it is 2, 4, 6, 8, 10 point what? 10.2 is divided by 5, so it is 10.4, right? This is 2. 2 divided by 4 is 0.5. Each box is 0.5. And this is 2, 4, 6, 6.8. No, 0.5, 2 point, no, that must be 7, right? Wait. Okay, let me see this. So again, so it is, each box is 2 divided by 4, which is 0.5. It's 0.5 actually, not 0.4. So it is 2, 4, 6, 8, 10, and 0.5, right? 10.5. 2, 4, 6, and half of 2, so 7. So AD is square root of 10.5 squared plus 7 squared, which is square root of 10.5 squared plus 7 squared. So this time, let's just find the decimal answers. So square root of that is 12.619. 12.619, and it's rounded, and it was 159.25. 159.25. What about BC? BC, this one. It is 246.5. 2, 4, 6, 8, 10.5. Wait, this is 7. 2, 4, 6, and half of 2 is 7. So it's 7 by 10.5. So we already know they are equal 10.5 squared plus 7 squared equals to 12.619. So these two are equal. What about here? 2, 4, 6. 2, 4. So AB, it's square root of 4 squared plus 6 squared, which is square root of 16 plus 36 is 16 plus 36 is 52. Which is, for that one, we can just leave it like that. BC, DC. It is 1, 2, 3, 4. 2, 3. No. 2. It's hard to read this, right? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Right? Each units are 0.5. 2 units are 1. So it is same thing. Square root of 4 squared plus 6 squared equals to square root of 52. So these two are equal. These two are equal. So we know opposite sides are congruent. So that could be parallelogram, right? But we are trying to check if they're all 90, meaning we have to look at their slope. So what's a slope? Rise over run. So slopes. Let me just go ahead and write a slopes of segment AD. AD, it's rise over run. So it is 10.5 over 7. What about BC? BC is also what? Rise over 10.5, right? Rise over 10.5, run 7. So they have same slope. But wait a minute, what are we trying to do? We want to see if they are perpendicular, right? We know these two are parallel, but let's compare with DC. DC, slope of DC and AB. What is DC? So we are not comparing these two. So DC is down 4, you see it? It's down 4, running 6. Down 4, run 6, so it is negative 2/3. AB is also down 4 over 6, so it is negative 2/3. So now we are looking at these two. Are they perpendicular? Are they negative and opposite? What's 10.5 divided by 7? Let's plug into the calculator and simplify that. 10.5 divided by 7 is 1.5, which is, when you hit math, enter, enter, it gives you simplified fraction, and that is equal to what? This is 3 over 2. When you divide by 3.5, it becomes 3 and 2, and this is 3 over 2. So when you look at these two, are they opposite and reciprocal? You see how they are opposite? This is negative, this is positive. And reciprocal means what? You flip top and bottom. Do you see it? What about these two? Are they opposite reciprocal? That means they are all perpendicular. So this is perpendicular, opposite reciprocal, opposite reciprocal, opposite reciprocal, and opposite reciprocal. So they are all 90. So you can say all 4 perpendicular angles. Therefore, it is a rectangle.